Hey YouTube, this is Mike, and in this video I'm going to be showing how to work out the odds in the game of Sic Bo. In case you've never heard of it, this is a game in which three dice are shaken, and there are all kinds of bets you can make on the outcome of these three dice. It used to be very popular in Atlantic City when I lived close to there in the 90s, and it was all over the place in Macau when last I was there. However, it seems to be going the way of the dodo bird in Las Vegas. I don't think there are any tables left. A good place to get started would be to work out the number of ways you can roll any given total of three dice. So let's start by calculating the same problem for two dice. What is the number of ways you can roll any given total with two dice? So we'll let column A here represent the roll of one die, and excuse me, I should have said column A, and row 1 the outcome of the second die. And the body of the table will simply be the sum of the two dice. So I'm going to add the sum of column A and row 1. And I'm going to copy and paste that formula through the whole thing. So you can see in the body of the table here, and I'll make it a separate color just to make it more clear. Here's all the possible totals you can get with two dice. You can see that they range from 2 to 12, and you can see that the most frequent total is 7. However, let's add everything up. So we'll have here a column. Let's create the possible totals from 2 to 12, and then we will count the number of times each of these totals appears in that table. So we're going to use the COUNTIF function. So there you indicate the range that you're searching over, and then a comma, and then what you're searching for. So this says that we found the total of 4 3 times. And I'm going to put dollar symbols here so that when I copy and paste this formula, the rows are going to stay the same. And there we go. Here we see how many ways you can roll each total with two dice. And it correctly adds up to 36 because 6 times 6 is 36. So next let's do the same thing with three dice. So I'm going to show you a little trick here. It's a little hard to explain, but this is a really clever trick, and it works for any number of dice and any type of dice. They don't have to be six-sided dice. So let's create some possibilities for the third die. It can be 1, 2, 3, 4, 5, 5 or 6. And the overall total can be anything from 3 to 18. So let's create that range there. Okay, so pay attention here. This is the humdinger. So here are our combinations for two dice. So I am going to, first I'm going to copy and then paste the values. So now we have hard numbers here as opposed to formulas. So if the third die is a 1, then the total of all three dice can range anywhere between 2 and 13. And so I'm going to copy down these 2 dice totals from there to here. So this shows the number of ways you can get any given total from 3 to 13 if the first die is a 1. Now the third die. If the third die is a 2, then the possible values of all 3 dice can range anywhere from 4 to 14. So again, I'm going to take that same range for 2 dice and copy it for the totals of 4 to 14. And for if the third die is a 3, I do the same thing for the range of 5 to 15, and so on. I just keep copying and pasting it, shifting one row down and one column over each time. And now, because every outcome of the third die is equally likely, I'm going to take the total of all 6 of those columns. And I'm going to copy and paste that down. And here we go. This shows us column H, the number of ways to get any given total from 3 to 18 with 3 dice. So I hope you appreciate that. I found this little technique very clever. Okay, so now we're ready to start analyzing some bets. So I made another sheet here for bets. And first let's analyze the bets on particular totals. So the player can bet on a total of anywhere from 4 to 17. And he can also bet on a total of 3 to 18, but it's done in a different way that I'll get to later. And so the standard win for a total of 4 is 60 to 1 in Atlantic City. For a 5, it's 30. For a 6, it's 17. For a 7, it's 12. And then it goes 8, 6, and 6. And then the whole thing reverses itself like so. So now let's get the combinations, which we already worked out from the other sheet, and copy and paste that down. And now let's get a probability. So it's going to be the number of combinations of ways to win divided by 216, which is 6 to the 3rd power. So there's the probability of any given total. And now let's get the expected return. So that's how much the player can expect to win on these bets. And if an expected return is negative, which it almost always is, it indicates the player can expect to lose. So let's look at the bet on a 4, for example. There's this probability, about 1.4% chance of winning. And if the player wins, he's going to win whatever it says under the pays column, plus 1 more unit, because he gets his original bet back if he wins, because these wins are all expressed on a 2-1 basis. So where we're at right now is, if the player bet, say, $1, he can expect to get back about 84.7 cents. But I'm going to subtract 1 because of the cost of that bet. So now where we're at is, this shows negative 0.15278. That means that for every dollar the player bets on a total of 4, he can expect to lose 15.3 cents. And we can just copy and paste that formula down. And let's put everything in the same number of decimal places. I'd like to go with 6. And let's make these columns a little bit bigger. So there we go. So let's see what is the best bet. It looks like the best bet is on the 7 and the 14 with a house advantage of 9.7%, and it's worse at a house edge of 16.7% on totals of 6 and 15. All right, let's move on here. So there's another kind of bet. I'm not sure what it's supposed to be called, but I'll call it the 1 to 6 bets. So the way it works is there's a place on the betting layout for 1, 2, 3, 4, 5, and 6. And the player wins according to how many times the chosen number appears between the 3 dice. Okay, so no matter what side you bet on, it can appear 3, 2, 1, or 0 times. If it appears 3 times, then the player's paid 3 to 1. If it appears twice, the player wins 2 to 1. If it appears once, the player wins 1 to 1. And if it appears 0 times, then the player loses. And I will designate that with a -1. Okay, let's just say, for example, the player bets on a 6. How many ways can a 6 appear on all 3 dice? Well, it's just simply one way. A 6, a 6, and a 6. And how about the number of ways that a 6 can appear on 2 dice exactly? Well, there are, of the 3 dice, the die that does not have a 6 can be any one of the 3. So we're going to put a 3 for that. And then that die that is not a 6 can be one of 5 things. So we're going to put 3 times 5. So there are 15 ways we can see 2 6s between 3 dice. And then how about 1 6? Well, there is one die that can have that 6. And for the other 2 dice, they can be any one of 5 things. So we're going to do 3 times 5 times 5. And then for 0 6s, all 3 dice can be anything from 1 to 5. So we're going to do 5 times 5 times 5. So there are our number of ways that a 6 can appear 0 to 3 times. And let's add these up to make sure it adds up to 216, which it does. So now let's take the probability. That's going to be the number of combinations divided by 6 to the 3rd power. And now let's calculate the expected return. That is the probability times what it pays. For example, with 3 6s, the expected return is the probability, which is 0.46% times 3, because it pays 3 to 1. And then we can copy and paste that formula down. And now let's take the total of both columns D and E. And let's put everything to 6 decimal places. 3, 4, 5, 6. So what does this show us? The bottom right cell has a value of negative 0.078704. So that means that the house advantage is 7.87%. Let's move on to what I call the domino bets. I call them the domino bets because on the layout of the table, they look like dominoes with 2 different numbers from 1 to 6. And there are 2 types. One I'll call the same face, where the player bets on the same face in both positions of the domino. So a 1, 1, 2, 2, 3, 3, up to a 6 and a 6. So with this bet, it can either win or lose. Nice and simple. And if it wins, it pays 10 to 1. And if it loses, the player loses everything, so I'm going to put a -1. So let's say the player bets on a 5-5. That's essentially betting on the number of times a 5 appears between the 3 dice, and the only way it can win is if it appears twice or all 3 times. Because basically we need to see at least 2 5s among those 3 dice. So we can use the math that we already did. For any given face, there's one way it can appear once and 15 ways it can appear twice. So there are 16 ways that this same face domino bet can win. And the number of ways it can lose is 75 plus 125, as we worked out before. So the probability of any given event is the number of combinations divided by the total number of combinations, which is 6 to the 3rd power. And the return is, for any given event, is the probability that it happens times what the player wins or loses if it does. So we can see that the expected return, and let's make this to 6 decimal places, is -18.5%. In other words, the house advantage on these bets, if it pays 10 to 1, is 18.5%, which is pretty high. So there are another set of 15 domino bets where the player bets on 2 different faces, for example, a 5 and a 6. So let's analyze those. We'll just copy and paste the same table, but let's change this to different faces to give the bet a title. And I happen to know that it pays 5 to 1. And let's get rid of these combinations for now and work them out. So let's just take the 5-6 domino as an example. One way the player can win at that is if the 3rd die is something between a 1 and a 4. So that other die can be anything from 1 to a 4, so 4 possibilities for that 3rd die. And then between, let's just say that the 3rd die is a 2. So there are 3 factorial, which equals 6 ways to order the 2, the 5, and the 6. And in Excel, we can use this fact and then put the number of items in parentheses. Again, just 3 factorial is 6. So there's 24 ways to win that way. The player will also win if he rolls either, and again in this example, a 5-5-6 or a 5-6-6. So let's add to that. For the 5-5-6, for example, there are 3 possible dice for that 6. So that's there's a 3 there. And then the die that is the singleton can be either the 5 or the 6. So let's multiply that by 2. So we get 30 ways to win. And let's just kind of cheat here. And for the number of losing combinations, that's going to be simply 216 minus 30. And so there we go. We can see in cell E40 that the expected return is negative 16.7%. In other words, a house advantage of 16.7%. So moving right along here. Another type of bet is on a specific 3 of a kind. For example, 5-5-5. And let's copy and paste this table down. So it's pretty obvious that there's just one way to win a specific 3 of a kind, and there's 215 ways to lose. And where do we get that 215? Well, we can go back up to this table up here, and if the chosen number appears twice or once or 0 times, we take the sum of those combinations and we get the 215. And winning bets pay 180 to 1. And so that shows us that bet on a specific three of a kind has a house advantage of 16.2%. Now let's say the player wants to bet on every single three of a kind. He can do that, and we'll call this the any three of a kind bet. And that pays 30 to 1. And how many ways can the player get a specific three of a kind? Well, there's 6. There's 6 possibilities for the three of a kind, 1, 2, 3, 4, 5, and 6. And then as we've shown before, once we've chosen a specific three of a kind, there's only one way it can happen. So there's 6 ways to win. And subtracting 6 from 216, we get 210 ways to lose. So that shows us that the house advantage on any three of a kind is 13.9%. And let's do the very last bet. Is actually a pair bet. It's called the small and the big. And let's talk about the small bet, for example. It pays even money if it wins. And the small bet will win if the total between the 3 dice is under 10.5 or 3 to 10. So the number of combinations for that is going to be, we can go back up to this table here and take the sum from cells C4 to C10, which represent totals of 4 to 10. No, let's let me explain it this way. Let's go back to the math sheet and look and take the totals for a total of 3 to 10. And that is 108, as expected, because there's 216 total combinations and half of them are under 10.5. However, the catch is that these bets lose on a three of a kind. So a 111, 222, and a 333 are all going to be a loser, not a winner. So we're going to subtract 3 from these winning combinations. And we don't subtract for a three of a kind and 4s, 5s, or 6s because those would result in a total of 12, 15, or 18, which would have lost anyway. So for the number of losing combinations, we can go back to our math sheet and take the sum of the combinations from 11 to 18, and we're going to add 3 for that 111, 222, and 333. And I added 33. Let's add 3. So there we go. We have a 48.6% chance of winning and 51.4% chance of losing. And cell E61 here shows a house advantage of 2.8%, making it the best bet on the Sic Bo table. So those are all the major bets. Sometimes you see some other bets that I won't get into. And for more information about Sic Bo, I would recommend my website, Wizard of Odds. And that is about it. Sic Bo is a pretty simple game. Hope you enjoyed this video. Give it a thumbs up if you liked it, and I'll see you in another video.